In this video, we will discuss about the average power in a resistive circuit. Suppose we have a resistor, let's say a resistor of resistance R, which is connected across an AC supply. We know the applied voltage V equal to V0 sine omega t, where V0 is the peak value of and omega the angular frequency. Clearly, a current flows through the resistance and let's call that current as I. Clearly, the direction of the current changes every half cycle since it is an AC. We have the current I in the circuit is equal to, it is I equal to I0 sine omega t. That is, there is no phase difference between current and voltage across a resistor. We already discussed that. The phase difference between the voltage and current in a purely resistive circuit is 0. Also, this I0 stands for the peak value of AC current. So we have the power at any instant, let's represent that as P is equal to, we have voltage into current. Also, you know power is equal to the rate of work done, dW by dt. Work done per unit time is defined as power. So I can replace this P with dW by dt. So dW by dt is equal to, I can plug in V0 sine omega t in here. So it is equal to V0 sine omega t, and for I have I0 sine omega t. Clear? So we have dW by dt is equal to, I can multiply these two and rearranging this equation, I'll get V0 I0, then sine omega t into sine omega t is sine square omega t. I can move this dt to the right, so the work done is equal to V0 I0 sine square omega t dt. Call that as equation number 1. So this is the small work done at any instant in a purely resistive circuit. So in order to get the total work, what you need to do is, let's represent the total work as W. What you need to do is to integrate this value from, see the variable in here is dt. So I have to take the value from 0 to t, where t stands for the total time. That is the period, one complete cycle of AC. In 0 to t, V0 I0 sine square omega t dt. Now, this V0 and I0 is constant, so that I can take out V0 I0 integral 0 to t sine square omega t dt. Now we have sine square theta. Sine square theta can be represented as 1 minus cos 2 theta whole divided by 2. So using this identity, I can write this as, this sine square omega t as, we have work W is equal to V0 I0 integral 0 to t. This will become 1 minus cos 2 theta, here theta is omega t, so 1 minus cos 2 omega t whole divided by 2 dt. Clear? I can take this 2 outside, so W is equal to V0 I0 upon 2 integral 0 to t 1 minus cos 2 omega t dt. Now we can integrate this. So W is equal to V0 I0 by 2. Now integral of 1 dt is t minus integral of 1 dt is t. Integral of cos 2 omega t is sine 2 omega t. You also have to put a 2 omega. That is, we have integral cos ax dx is actually sine ax divided by this constant a plus some c. We don't have to worry about the c in here because this is a definite integral. That is, we have the limits. Now I can put the lower limit in here and the upper limit here. Now W is equal to V0 I0 by 2 into t. Before putting the upper limit and lower limit, I can change the value of omega. So this is equal to sine 2 into omega is actually 2 pi by t. So I can replace omega with 2 pi by t. 2 pi by t, then this t whole divided by 2 omega. Now the limit 0 to t. So the work done W is equal to V0 I0 by 2 times t minus sine 4 pi by t into small letter t whole divided by 2 omega. Now I can put the lower and upper limit. First I can substitute the upper limit. So the work W is equal to V0 I0 by 2. In place of the small letter t, you just put the capital T. So t minus sine 4 pi t into t by 2 omega. This is the upper limit minus the lower limit. You can put the value 0 for the small t. That is 0 minus sine. When you put 0 in here, this whole term will become 0. So sine 0, this whole term becomes 0 by 2 omega. Clear? Now simplifying this, you will get W is equal to V0 I0 by 2 into t minus, this will become sine 4 pi, but sine 4 pi is actually 0. This whole term will become 0. This is also 0. Sine 0 is 0. So no need to write this term. So the value will be t minus 0. So the total power W is equal to V0 I0 times t divided by 2. Call this as equation number 2. Now we need to find the average power. We know average power P average is equal to the total work divided by the total time. You can write like this also, W into 1 by T, which is equal to, I can place V0 I0 T by 2 in place of W into 1 by T. Cancel this T and T. So the average power is equal to V0 I0 divided by 2. So this is the expression for average power in AC circuit, in a purely resistive circuit. Also you can write this in this way also. P average is equal to V0 by root 2 into I0 by root 2, because after all root 2 into root 2 is actually 2. So this value is VRMS. So P average equal to root mean square value of voltage into root mean square value of the current. Clear?